Okay, so let's look real quick at finding the value of a function. So we can use what's called a function notation to write an equation. Remember, an equation is one way of representing a function. So if we have the equation y equals 2x minus 5, another way of writing that is with this function notation. We say f of x equals 2x minus 5. So this f of x replaces our y. And it's really important. This is a huge thing. If you can remember this, it'll help you out on a few problems on the homework. That y and f of x are interchangeable. If you see an f of x, you could put a y there. If you have a y, you could put an f of x. Okay, those two basically are representing the same thing. So y equals 2x minus 5 is the same as f of x equals 2x minus 5. And if we want to use that, this is called function notation, f of x. We can use that to show the value of a function at some x value, say x equals 2. We instead of f of x, we could say f of 2. Okay, and what happens is we had f of x and 2x, so f of 2 becomes 2 times 2, and if you work that out, we get a negative 1. So that's why we say f of 2 here is equal to negative 1. We call that function notation. We're going to use that a lot as we look at different functions. And we already talked about this earlier, but for some function y equals f of x, x is the independent variable, y is the dependent variable. So going back and looking at evaluating a function, here we have f of x equals 2x squared minus 3x. We want to evaluate the following. So for that function, what's f of 3? Okay, the key here is the x became a 3. So we could say, instead of 2x squared, 2 times 3 squared minus 3 times 3. Every x is now a 3. Parentheses here around the 3's are pretty important as we kind of work this out using order of operations. First we start with the exponent. 3 squared is 9. And then multiply, that's 18 minus 9. 18 minus 9 is 9. So we would say that f of 3 equals 9. Okay, example 10, what's f of x plus f of 3? So here I've got two different function notations, f of x plus f of 3. So to evaluate that, well, what's f of x? Didn't we say f of x was 2x squared minus 3x? That's f of x. We're going to add to that, what's f of 3? Well, we just said that f of 3 for this function is 9. So f of x plus f of 3, well, that's just, if we kind of rewrite that, 2x squared minus 3x plus 9. So we can take those two function evaluations and just kind of stick them together like that. 3 times f of x. So we want to take f of x, the entire function, and multiply it by 3. So we take the entire function f of x. Here's f of x here. And we're going to multiply that by the 3. And we can just distribute here. 3 times 2x squared is 6x squared. 3 times 3x is 9x. So that's 3 times f of x. F of negative x, again, every x in our function is now going to be replaced by a negative x. And the parentheses are really crucial here. So it was 2x squared minus 3x. Now it's 2 in parentheses negative x squared minus 3 parentheses negative x. And you want to simplify this down. If you square a negative x times negative x, okay, negative times negative just makes that a positive, right? So the negative cancels out. Minus 3 times the negative x. Again, negative times the negative just makes that a plus 3x. So that's f of negative x. Now that f of negative x, we're going to be using that sort of evaluation later on in some problems, and so it's important to kind of understand how to plug in negative x into a function. So you're going to be seeing that later on as we eventually start talking about what are called even and odd functions. But that's f of negative x. 13 is f of, let's see, we just did that, didn't we? F of negative x. So let's skip that one. It's a typo. 14, the opposite of f of x. So we're just going to place a negative sign outside that function. Notice the whole thing in parentheses with a negative sign out front. And again, you can distribute that negative sign. You get negative 2x squared plus 3x. Just flips those signs around. F of 3x. So now every x becomes a 3x. Looks like this. Again, if you simplify this down, exponents first, that's a 9x squared. If you square the 3x, 3 squared is 9x squared. And then simplifying that down, 2 times 9 would be 18x squared minus 9x. 3 times 3 is 9. So that's f of 3x. 16. Every x is now an x plus 3. Hopefully now you're catching on that just whatever's inside these parentheses, you can put it in parentheses and just drop it in just like so. So evaluating that, again, starting with the x plus 3 squared. Okay, if we square an x plus 3, think about what that means. Isn't that multiplying a binomial by itself? And how do we do that? We do FOIL, right? So x times x is x squared. Outside terms are 3x. Inside terms are 3x plus 9. So combine those two. X squared plus 6x plus 9. Okay, so the x plus 3 squared we can replace with x squared plus 6x plus 9. Tell you what, we can also go ahead and distribute that minus 3 there. Just kind of knock that out. Minus 3x minus 9. Next, we need to distribute that 2. So 2x squared plus 12x plus 18. And then bring down minus 3x minus 9. And now combining a couple of like terms, 12x and minus 3x make a plus 9x. 18 minus 9 is 9. So that's f of x plus 3. It's 2x squared plus 9x plus 9. Okay. 17 is the last one in this set. Now this one's a little, I'm going to get some space here. This one is a little frightening to look at. Let me just rewrite this a little bit larger. F of x plus h minus f of x divided by h when it says h is not 0. Okay, the only thing that does is just make sure we're not dividing by 0 there on that denominator. But if we want to evaluate this, now where did they get this thing from? Well, this is actually you guys that are planning on eventually taking calculus someday. You'll spend a lot of time working with this fraction. We call it the difference quotient. And it's kind of one of the first things you start looking at in calculus. And so one thing you'll do is you'll take this difference quotient for a bunch of different functions and evaluate this for whatever function. So maybe like ours, 2x squared minus 3x, we evaluate that difference quotient. So what's that going to look like? Well, probably the best way to handle this is first let's just look at f of x plus h. Just kind of take this in pieces. 2 times x plus h squared. Let's see, it's plus, let me get this, no, it's minus 3 times x plus h. Okay, so working that out, again, just like we did up here earlier with the x plus 3 squared, you can FOIL x plus h. You're going to get an x squared plus 2xh plus h squared. Okay, you can just trust me on that. And then distribute all this goodness on both of these. So 2x squared plus 4xh plus 2h squared, and then minus 3x minus 3h. And you want there to be like terms, but sure enough, there's not any. Okay, so that's f of x plus h. I'm just going to drop that in. Up here, 2x squared plus 4xh plus 2h squared minus 3x minus 3h. And then wasn't my function, and I'm going to, sure enough, run out of room here. Let's see if I can maybe scoot this. Okay. I need to subtract f of x from it. So minus, what is my f of x? It's 2x squared minus 3x. Divide all that by h. Okay, so if you'll notice what's going to happen here, I've got a 2x squared here. And aren't I subtracting a 2x squared? Aren't those going to cancel out? And then I've got a minus 3x here, and I'm subtracting a minus 3x. So those will actually cancel out as well. So this whole piece here on the end cancels out. So if I bring this down, I've got a 4xh plus 2h squared minus 3h divided by h. And if you'll notice, that numerator, all of those terms have h's. So I can actually factor out an h. Okay, what happens is, once you factor that out, you get these h's that cancel, numerator and denominator, and you're left with 4x plus 2h minus 3. So that would be your final answer there for example 17. It's kind of a beast of a problem. I don't think I put any of those on the homework, but just know that if you do take calculus someday, you have that to look forward to. So enjoy. And then the last thing we'll look at as far as evaluating functions is how to evaluate using your calculator. So hopefully you've got one of those TI-84 graphing calculators or something similar to it. We can actually use those to evaluate these functions. So the first one, and just running through these real quick, f of x is x squared. We want f of 1.234. There's actually a couple of different ways you can do this. One way is just to say, okay, well, f of 1.234 is 1.234 squared, right? So I can just take 1.234 and square it. And I get 1.522756. for my answer. So that's easy enough. There's actually another way you can do that using variables. Now you guys have probably in math class, especially if you're straight out of high school or recently been in high school, I'm sure you're all guilty of passing messages back and forth on the calculator because you can, this alpha button, you can get different variables using that alpha button, and so you could, if you're real clever, you could type messages to your neighbors and send those. And we have those letters there. We can actually use those letters as variables if you know how to use them. So say I want to do an x squared, where x is 1.234. First thing I need to do is I actually need to tell the calculator that x is 1.234. And the way I do that is I type in my x value, and then there's this store button. This is like a little arrow, and I want to tell it that 1.234 is stored as x. And so I can actually hit either alpha, see the little green X right there, alpha store, or I can just hit this button right here to get an X. And what that does is that says to the calculator, I want that to be X. So now if I want X squared, I can just hit X squared, and there it is. And you're thinking, well, that was a lot of work just to square that number. But what's really neat is if you'll notice, these other questions were evaluating the same thing. Here's f of 1.234, g of 1.234 for 1 over x and the square root of x. And so what I can do once I've got that value stored, if I need to put it in another function, I could say 1 divided by x. For the next one, that's 0.810. And if I want the square root of x, I could say what's the square root of x? It's 1.110, 1.1111. So I can reuse that in any different function. When I use that x now, now that I've stored that value, x, if I just put an x in, is 1.234. Okay. Now where this is really helpful is if you've got some big nasty function. Maybe I want to do 2x squared minus 3x using that x value. Well, I can actually just type that in, 2x squared minus 3x, and it'll plug that x value into that function. So you can take a big complicated function, some polynomial that normally is maybe a little bit tricky to get something plugged into, store it as that variable, and then run it through just like that. So just a calculator trick. Now there's nothing wrong with just doing it like this, like we did earlier. Just wanted to show that to you.